Here's our introduction to multiplication properties of exponents. We have two rules. One of them we'll get through today. The other one I'll have on here. I'm not sure if we will get through it though. So when multiplying exponents and the bases are the same, you will keep the base and add the exponents. So the example up here, 3 squared, 3 is the base and 2 is the exponent, and then x to the fourth, x is the base and 4 is the exponent. So the first example is 3 squared times 3 to the fourth. Because these bases are the same, they're both 3's, you're going to keep that base, and then you're just going to add the exponents, which is 2 plus 4. Your answer is 3 to the sixth. Right now, just keep it at 3 to the sixth. I won't worry about expanding it out yet. The next example, 2 to the fifth times 2 to the sixth. Both these bases are the same, so you just carry it over. Add the exponents, 5 plus 6, you get 2 to the 11th. The third example, a to the fourth times a squared. These bases are the same, so you carry it over. You just add the exponents, 4 plus 2 is 6. The last example, you have y squared times y to the negative fourth. So we're going to keep the bases and add the exponents. 2 plus negative 4 is negative 2. But if you remember, we don't want to have a negative exponent. So because the exponent is negative, we draw that fraction bar, we drop it down to make it positive, and put a 1 on top. Here's some more practice examples. All of these are multiplication. A to the fourth times b squared times a to the third. These a's are the same, so you're going to keep them. 4 plus 3 is 7, and then you're left with b squared. Because the bases are different, you can't do anything. It's just going to be a to the seventh b squared, or a to the seventh times b squared. The next example, 2 to the fifth times 2 to the seventh. These bases are the same. Keep the base. 5 plus 7 is 12. A squared times a to the ninth. These two 8's are the same. 2 plus 9 is 11. 3 squared times 4 squared times 3 cubed. These are the same. Keep the base. 2 plus 3 is 5 times 4 squared. And later on we will expand it where we would get 4 squared is 16 and we would just multiply. But you can keep this just like that for now. Multiply. X to the fourth times x squared. Bases are the same. 4 plus 2 is 6. Now here we have x to the negative fifth times x to the fifth times y to the sixth and y to the negative eighth. So let's work with these x's. Negative 5 plus 5 is 0. Y to the sixth, y to the negative eighth is y to the negative squared. Anything raised to a 0 power is 1 times y to the negative 2. But remember, don't want a negative exponent. Drop it down below the fraction bar and keep your 1 on top. That's your final answer. Last one on this page. Y to the negative 3, y to the negative 2. So this becomes y to the negative 5 times x. 4 plus negative 1 is 3. We don't want that negative exponent, so we need to draw our fraction bar, bring it down, x to the third on top. Here's some practice in the book, page 464. Got 1 through 4, 6 through 8, 19, 20, and 21. If you just work on these in your spiral, you can do them on the left-hand side, or if you're running out of room, you can always use another sheet of paper. And then you can stop the video and work on these. The next slide has the answers for 1 through 4 and 6 through 8. and then I will skip that slide and then continue with the next part of the lesson. There's your answers. Multiplying rule number 2. To raise a power to a power, multiply the exponents. So take a look at this example. This says 2 to the third power, all raised to the second power. So we're raising 2 to the third to that second power. You can expand it out. So you know that 3 squared is simply 3 times 3. Well, that's basically what this is saying here. All of this whole power, 2 to the third, is being expanded out twice because of the exponent 2. And if we go back and think of our rules that we just learned, this problem says 2 to the third times 2 to the third. Bases are the same, keep the base, and add the exponents. Or you can do a shortcut, and then you can just multiply the 3 and the 2 from up here. So this would look like this. 2 to the third raised to the second power would be 2 to the sixth. Multiply the 3 and the 2. We'll do some more practice. 7 to the fourth raised to the third power. 4 times 3 would give you 7 to the 12th. X second, the second power, raised to the fifth power would be x to the 2 times 5, which is x to the 10th. All right, my 10's a little messy. X to the third raised to the second power is x to the 6th power. A few more examples. X squared to the negative 4th power is x to the negative 8th power. Can't have a negative. 1 over x to the 8th. 6 to the 0 power raised to the third power. 2 ways you can look at that. Go ahead and multiply. 0 times 3 is 0. Anything to the 0 power is 1. Or you could even start inside here and say 6 to the 0 power is 1 raised to the third power. Now this is a tough one. I got a negative 3. Do I bring it down to the denominator? You're right, no, because we need to look at the exponent to determine that. So this is simply multiply the exponents again, negative 3 to the 8th power. Nothing needs to get moved because the 8 is positive. It's just negative 3 to the 8th power. Now here's where it's going to get a little tricky. We have 2 terms inside the parentheses. Because there are 2 terms in here, you need to share that 2 with both. So this is going to be negative 3 squared x squared. Forgot to put a 2 on that one. Same thing here. This is going to be 4 squared p squared. And then this is going to be x to the 8th, y to the 12th. I got to go back up here and put my parentheses in. And then if we wanted to go ahead and simplify, negative 3 squared, remember negative 3 times negative 3, because it's in parentheses, would give you 9x squared. This would give you 16p squared, and this last one is finished as is. I will put some other practice problems up for you on the website, and double check. I think your homework will be limited to the first multiplication rule.